Hey everyone, we're back for another science lesson. I think we got a couple lessons coming up, and I'll be attaching some worksheets with those, and then we'll get into doing another lab. So today I'm going to start to explain the periodic table a little bit more to you. So first of all, when you go to periodic table, you'll notice for hydrogen here that there's a couple numbers. The first is this number up here. It's not always in the top left-hand corner. But that number is the atomic number. Atomic is a fancy word for atom. So that's the atom's number or the atomic number. And there's another number here, and it's the one rounded to a decimal place. That is the atomic mass or the weight of that. So hydrogen here has an atomic number of 1. What that tells me is that in the nucleus of hydrogen, it has 1 atom. If we look at zinc right here, it has an atomic number of 30. That tells me that zinc has 30 protons in its nucleus. And so hydrogen has 1 proton in its nucleus. Potassium, atomic number 19, 19 protons in its nucleus. Only potassium has 19 protons. If it has 20, it's calcium. If it only has 18, then it's argon. So that's how we can tell the difference between the different element types based on the number of protons, and that's the atomic number. The weight of an atom is made up of, if you recall, protons and neutrons. Each has a value of 1. Electrons, while they do have weight, it's so small and insignificant that in grade 9 we just ignore it. So when I look at hydrogen here, I can see that it has 1 proton, but it also rounded. What is this doing here? Rounded, it has a weight of 1.01. So we would just round that back to 1. You round it to the nearest whole number. That tells me that hydrogen has no neutrons. It only has the 1 proton, which accounts for the 1 weight. If I look at lithium, we know it has 3 protons, because that's the atomic number, but it has rounded a weight of 7. So 3 of the 7 weight units comes from the protons. That must mean the remaining 4 come from the neutrons. So that tells me that lithium in its nucleus has 3 protons and 4 neutrons, because 3 plus 4 gives us a weight of 7. Likewise, beryllium here. 4 protons in its nucleus. It has a weight of 9, rounded. So we know that beryllium has 5 neutrons. 4 protons plus 5 neutrons gives it a total weight of 9 units. So the atomic number, which I mentioned, is the number of protons in its nucleus. It's unique to each element. So lithium will have it'll have 3 protons. Only lithium can have 3 protons in its nucleus. And the mass number is the number of protons and neutrons added together. Now, atoms are neutral. They don't have a charge. We know that protons have a positive charge. We know that electrons have a negative charge. So in order for an atom to be neutral, it must have the same number of pluses and minuses, negatives and positives, protons and electrons. So if lithium here has 3 protons, which would be a plus 3, it would also have to have 3 electrons, giving it a negative 3. The two balance each other out and we get 0. Magnesium here, 12 protons, so it would have 12 electrons as well to balance out and give it an overall neutrality. So this here, this X is just representing, say, lithium, so that would be the element symbol, so we'd put an Li here. The mass number we know is 6 point something, 6.93 or something like that, so rounded it would be 7, and the atomic number is 3. And the mass, of course, is the protons plus the neutrons. So for helium here, helium-4 has a atomic number of 2. So that tells us that it has 2 protons in its nucleus. It would also have 2 electrons to make it overall neutral. And the weight is 4. So that tells us that if it has 2 protons, it must also have 2 neutrons to give it that weight of 4. Now an isotope. Perhaps you've heard this word before. An isotope is a different form of an element. So hydrogen has 3 isotopes. There's 3 different versions of hydrogen. This bottom number here is the atomic number. Hydrogen is hydrogen because it has 1 proton in its nucleus. That's what makes it hydrogen, 1 proton. But you'll see here that there's 3 different versions that have a different weight. This one has a weight of 1, this one has a weight of 2, this one has a weight of 3. What that means is this one here has 1 proton and no neutrons, hence the weight of 1. This one here has its 1 proton, that's what makes it hydrogen, but it also has 1 neutron for a weight of 2. And this one here has 1 proton, that's what makes it hydrogen, but it has 2 neutrons, which gives it a weight of 3. Some elements have isotopes, some don't. Going back to our periodic table, carbon has 3 isotopes: carbon 12, carbon 13, and carbon 14. Carbon 12 by far is the most prevalent one. 13 and 14 are a lot rarer. So carbon has atomic number of 6, meaning 6 protons in its nucleus. And rounded, it has a weight of 12, which means for carbon 12, it has 6 neutrons as well. Carbon 13 would have 7 neutrons. Carbon 18 would have, or 14, sorry, would have 8 neutrons. When you take the carbon elements with a weight of 12, with a weight of 13, and a weight of 14, and you add them all together and you average it out, you get an average weight of 12.01. Because it's so close to 12, that actually tells us that carbon 12 is the most prevalent isotope. 13 and 14 are a little bit more rare, or a lot more rare. And for our purposes in grade 9, we just round this back, and that'll give us the most common isotope. So the most common nitrogen isotope is nitrogen 14. There's also a 15. I can't remember if there's a 16 or 17. That's something that I have to look up again. Once again, we don't have to memorize the periodic table, but if we know what these numbers mean, we can very easily Google and find out the information that we need. So that's an isotope when the weights differ. And the atomic mass is the average mass of all the isotopes. I just discussed that. Now, we discussed Bohr and Rutherford, how they have given us our most modern version of what an atom is. And so we're going to spend some time drawing Bohr-Rutherford diagrams. And these are just basically simple drawings that show where the protons, neutrons, and electrons are. So this is a Bohr-Rutherford diagram for F19. This is fluorine 19, the most common fluorine isotope, has a weight of 19. In the nucleus here, we know that fluorine, if we look at the periodic table, has atomic number 9, so it has 9 protons. So we just write 9p. This should actually be a 9p with a little plus. And if we look at fluorine on the periodic table here, so there's atomic number 9. It has 9 protons in its nucleus. It has a weight of 19. So that tells me that we must have 10 neutrons as well, because 9 and 10 gives us a total weight of 19. Now for this atom to be neutral, it would also have to have 9 electrons. So we know that they orbit the nucleus. So here's the first orbit. We call this the first orbit, the first shell. And we know that the first orbit can only have 2 electrons in it, and then it's full. So then we draw in a second orbit, and so we know we have 9 electrons. So here's 1 and 2 in the first orbit, The rest go in the next orbit. 3, 4, 5, 6, 7, 8, and 9. And remember that second orbit or shell can hold 8. Remember 2, 8, 8. First orbit holds 2, second and third hold 8. So this second orbit could actually hold one more, but we don't have any more. So there's our 9 distributed. So for carbon 12, perhaps I'll do another little YouTube video showing how to draw that. But carbon 12, carbon has an atomic number of 6, so we'd put 6 protons in its nucleus. It has a weight of 12, so that would be 6 neutrons as well. And it would have 6 electrons to make it neutral. So you would draw your first orbit and put 1, 2 in it. You would draw your second orbit and you would put 3, 4, 5, and 6. So there would be 2 electrons in the first orbit, 4 in the second orbit. I'll do another little tiny video to show you that. So by examining Bohr-Rutherford diagrams, we can start to see patterns that emerge as well. So this is protons 4, 12, and 20. If I can go to the periodic table, we can see 4 is beryllium, 12 is magnesium, and calcium is 20. They are all in the same family. And not only do they look the same, but I talked about in a previous video how they act the same. And the reason they act the same is kind of because they look the same. So I'm going to explain that as well. If you notice here, beryllium has 4 protons, so it had 4 electrons, 2 in the first orbit, 2 in the second orbit, and the outer orbit we call the valence orbit. That's the term for it. Magnesium here has 12 electrons as well, because there's 12 protons. So 2 in the first orbit, 8 in the second orbit, and 2 in the outer or valence orbit. And calcium, 20 protons, 20 electrons. 2 in the first, 8 in the second, 8 in the third, and 2 in the fourth orbit. Notice that all these have 2 in the outer orbit. That's what makes it very reactive, that there are 2 electrons in the outer orbit. If we go back to the periodic table, you'll see when you draw these up, all the alkali metals have 1 electron in its outer or valence orbit. That's what makes it very reactive. All our alkali metals here have 2 in its outer orbit. That's what makes it very reactive as well. Our halogens over here, they all have 7 in their outer orbit. That also makes it very reactive, and I'll explain why in a little bit. And our noble gases, which aren't reactive at all, they have a full outer orbit. Helium has 2 out of 2 in its outer orbit. Neon, argon, krypton, they all have a full 8 out of 8 in its outer orbit. Actually, krypton has a full 18 out of 18, I believe. So, because the outer orbit is full, that makes it unreactive. So as you go down the family, you'll also see a new orbit is added. I talked about the periodic table having a lot of information in it. This row here, 1 orbit. Lithium right across the neon, 2 orbits. Sodium across the argon has 3 orbits. Potassium, 4 orbits. Rubidium right across the xenon, 5 orbits. So when I look at magnesium, I know that it has 3 orbits because it's in the 3rd row. And I know in the outer orbit, it has 2 because it's in our 2nd family. Potassium, I know it has 4 orbits. It's in the 4th row. And because it's in family number 1, I know it has 1 electron in its outer or valence orbit. Likewise over here, bromine, 4th row, 4 orbits. Remember, we renamed these. So this was 3, 4, 5, 6, 7, and 8 for families. This would be family 7. So it would have 7 electrons in its outer orbit. All right, coming to the end of my time here, so I'm going to start a new video in a moment.